Hello, ladies and gentlemen. I am Dr. Claudia Albers, Planet X research and professional physicist. And today I'd like to bring to you another one of my articles. This one's entitled Planet X Observation-Based Energy Conversion in the Course of Planets and Stars. Now, planets emerge from within stars, and you may look at Article 541 entitled Planet X Cover-Up and Planetary Formation. Where do asteroids come from? They are the result of a matter creation event inside a star. Stars and planets create both matter and give off light. They do so by converting gravitational photon energy, which is photon energy within particles, into both matter and light, which is in the form of free photons. The matter emerges in the liquid form from within the core, which suggests that the core itself is not solid. The core is also in the liquid phase, like the magma, which it creates, but is hotter and denser than the magma that is outside the core. The Planet X system cores, however, seem to be solid, which is to be expected since they are too low on energy to be able to convert light into matter. And you may look at Article 532 entitled Planet X or Comet Re-energizing Process. And this is illustrated here. And this is a Planet X observation-based planetary formation, which agrees with Alton Harp's galaxy observations, where he saw galaxies ejecting matter which condensed into quasars, which then formed their own matter, ejected their own matter, and caused the appearance of the arms of the galaxy. And so a star ejects liquid plasma, and you can see that here, which condenses into a core, which then ejects its own material so that the outer layers of the planet forms. Now, the energy is released from within particles as free photons. They are then converted to matter or particles, and the excess goes back into the in-particle form of gravitational energy, which can also be described in terms of heat. Energy in this form can also flow from particle to particle through collisions. Particles with more of this energy in them will tend to vibrate and move faster, which is equated to heat. The highest vibrating particles are the hottest, and they will have the most gravitational energy in them. This is why magma is hot, and hotter the deeper it is inside the Earth. When particles collide, the heat from the most energetic particle flows to the one with the least amount of energy, so that they both end up with the same amount of energy. I call this the principle of equal energy sharing. And this is illustrated here. If you have high temperature particles, they move at high speeds. Low temperature particles move at low speeds. When they collide, they exchange energy, where the particle with less energy will end up with more. They end up with the same amount and thus moving at the same speed. So the energy released by the core of an established planet will go into the emission of infrared radiation by the surface of the planet. The energy release will reach a steady state in which all the layers are kept at the same energy level or temperature. In other words, constant for each layer, but differing across the layers, with the inner layers being hotter. And a continuous and constant amount of energy is given off by the planet. An established star would also maintain its generation of energy at a steady pace in order to maintain its chromospheric layers at a constant temperature, but it will also continuously give off matter as well as light. The matter given off is its solar wind, and the light will be given off by its atmosphere, which is kept in plasma arc mode by the extremely high amount of gravitational photon energy in the electrons in its outer atmospheric layer. And this is illustrated in this diagram. So a star generates energy through nuclear reactions in the core, and these nuclear reactions are things like the converting of protons to neutrons and radioactive decay, which then releases free photons. Free photons emerging into the high electric field which there is a very high electric field here inside the core, split into particles which go into the production of star wind, because as the matter emerges, which is in the form of liquid plasma, it emerges and moves upwards through the layers. Eventually it arrives at the surface and is then ejected as solar wind. At least part of it will, and part of it will remain behind. Most of the electrons will remain in the upper layers of the atmosphere and will go into creating this very large electric field in the outer layers of the star, which then allows that part of the star to go into plasma arc mode and emit large amounts of light. Energy in the core is generated through a more energetic means than through collisions and conduction. Therefore, as the high energy and density state of the core results in nuclear reactions. Particles release photons when neighboring particles have lower energy, but the release of photons sometimes lowers the gravitational energy of a proton or an electron to the point that they are no longer strongly enough repelled by each other through the charge separation part of the gravitational interaction, and are thus brought together by the electrostatic interaction, which turns them into a neutron. Some of the energy is converted to mass and some is given off as free photons, so that the resulting particle has the same energy as other particles in its environment. And these reactions that I've talked about are illustrated here. First of all, a photon has a proton and an electron within it, but without mass. They are just oppositely charged. When the photon moves through a region of high electric field, these particles are forced to move in opposite directions, responding to the electric field. And that means they split apart, they come out of the photon. Then the photon goes into producing mass for the particles, and the rest exists as gravitational photon energy within the particles. It's actually part of a photon within, it's actually photons within particles. And now a neutron is formed when one of these particles may not have enough energy to produce a strong enough gravitational repulsion between the two, which then causes the electron and the proton to come together and form a neutron. And here what we have is a lithium atom, and this illustrates what happens. It actually shows that photons exist within particles, because what you have is two forces acting on the electrons. You have the gravitational repulsion, that's due to the gravitational interaction that causes protons and electrons to repel, that's represented by the green arrow, and you have the electrostatic attraction, which causes protons and electrons to attract. And that means that these two forces are basically keeping the electron in a certain region just outside of the nucleus. If it tries to move too close, this force gets stronger, so it cannot. And if it tries to move too far away from the nucleus, then the electrostatic attraction gets stronger and brings it back. So it's basically trapped in a region outside the nucleus. But when an electron absorbs a photon, it gains gravitational energy. So this force, the outward green arrow force, will get stronger. So this electron will tend to move up into a higher energy level, and sometimes it will leave the atom entirely if it gains enough energy for that. Now, so in addition, some protons and neutrons may turn into neutrinos, where now most of the mass is also turned into photon energy, because neutrinos have either no mass or extremely low mass. This suggests that neutrinos are essentially a very low mass version of the neutron, which, because of that extremely low mass, do not interact through the strong force part of the gravitational interaction. And this is illustrated here. We have the electrostatic interaction, which causes protons and electrons to attract. So they tend to come together, 2 protons to repel and 2 electrons to repel. The gravitational interaction is opposite to the electrostatic. So a proton and an electron will tend to repel. That's why I call this the charge separation part of the gravitational interaction, because it separates the particles. And this is the strong force part, which is an attraction between 2 protons. And the interaction is dependent on the mass of the particles. The proton is much more massive, so the interaction between 2 protons is much stronger than the interaction between a proton and an electron. But it also depends on the gravitational photon energy, which is photons within the particles. And that means if there's more energy within the particles, the interaction, the force ends up being stronger. A star's internal electric field drops when protons become neutrons or neutrinos. Thus, over time, the core of a star will be converted into neutrons and its internal electric field will decline, which means that a star will end up as a neutron star. When a star becomes a neutron star, in other words, most of its protons have combined with electrons to form neutrons, it will no longer be able to create mass or emit light. It would have died. The dead star would also be very low in gravitational energy and thus have a very low ability to interact gravitationally and will therefore have a very weak gravitational field. Hence, a neutron star is a dead star. It will not give off light, and it will only generate extremely weak gravitational and electric fields. Planet X system stellar cores, however, are dead or energy depleted, but are not neutron stars, which agrees with the idea that they died suddenly when energy suddenly departed from the core. And you may look at Article 513 entitled Planet X planets or exploded planets. In other words, if they had died slowly, they would have turned into neutron stars. But because they did not turn into neutron stars. They turned into depleted objects that are not as dead as neutron stars because they still have a strong electric field. So the loss in energy would cause the core and magma to become cold and solidify, and also cause the core's gravitational influence over the outer layers to suddenly drop. These outer layers would be under severe pressure due to being pulled inward toward the core. So now with the inward force gone, they would explode outwards and break into pieces, turning into a huge debris field of rocky pieces and dust. This would occur with both stars and planets, and this is illustrated here. A living celestial object turns into a Planet X system stellar core when its gravitational photon energy suddenly was removed, causing the liquid layers to solidify, all atmosphere to be lost, and most of the gravitational field to be lost too, so that outer layers explode outwards and break into pieces. The object will thus be made up of its original core and will be surrounded in a debris field. The atmospheric matter and thus electrons in the atmosphere would not hold on to the debris pieces and would thus escape into space and be lost, leaving a positively charged core and debris field behind, although some pieces that were part of the surface would remain neutral. The liquid water turned into tiny droplets or clouds and was attracted via the electrostatic interaction to positively charged pieces of debris and the core. In the core, the loss of gravitational photon energy would cause as many protons and electrons as possible to combine into neutrons or neutrinos, and many radioactive nuclei to quickly decay, which would release gravitational energy, which would then be shared through the core. This would be the core's last reserve of energy, which would allow it to retain a very weak gravitational influence and field. With protons combining with electrons to form neutrons or neutrinos, there would be a loss of positive electric charge and thus electric field. But since a huge number of electrons were lost because they were a part of the atmosphere, there would be plenty of protons left to continue to generate an electric field, which would thus remain much stronger than the gravitational field. It is this electric field which allows a Planet X system stellar core to induce a matter creation event in the core of a living solar system celestial object, which then results in a volcanic eruption or earthquake in the case of the Earth, or CME in the case of the Sun. And this is illustrated here. Living celestial object's positive field ends at the surface, but a Planet X system stellar core's field does not end. So this one ends at the surface because the surface is neutral, and after the surface there's a negative electric field. But for the Planet X object, there is no negative electric field on the outside. It's lost its electrons. So this electric field does not end. It keeps on going beyond the core of the object. So this, the fact that it does not have a negative outer layer actually allows it to enter the atmosphere of a living celestial object. Then if the object is as large as the living celestial object's core or larger, that means that its electric field will extend all the way to the core and still be quite strong at the core. Then as its electric field overlaps the living object's field, an instability occurs which results in a matter creation event. The core releases a large amount of gravitational energy which gets converted into matter. And this is what you see here. So the Planet X object's positive electric field causes positively charged magma in the Earth's inner layers to either move inwards towards the core, and that's illustrated by this black arrow, in the opposite direction in which it normally moves, because it usually moves outwards towards the surface, or it will slow down its normal motion, which causes energy in the core to build up, resulting in an instability, which then results in a very large release of gravitational photon energy as high energy free photons, which then split into particles as a result of the high electric field environment. And this causes an explosion of newly created matter moving outwards toward the surface in the direction of the stellar core. And this is illustrated by this pink mass here. That's the newly created matter which explodes outwards, moves quickly through the layers, pushes magma right out, and causes volcanic eruptions. And this core may then attach some of that matter to, or allow some of that matter to attach to its surface, so it will draw matter from the Earth to itself, to its surface, and it will absorb the energy within its matter and therefore gain gravitational energy. In a newly formed planet, star, galaxy, what causes the matter creation is the fact that the core has too much energy for its size, as it will have close to the same amount as the core of its parent, but it will be much smaller. The large amount of gravitational energy for its size causes instability. In other words, there is an imbalance between the amount of energy being released by the outer layers and the energy inside the core, so that matter creation is triggered until a balance is achieved. This causes the size and mass of the new celestial object to increase. Once it reaches the appropriate mass and size for the size of its core, the energy generation will slow down to a maintenance level, where a steady state in energy flow from the inside is reached. So, in conclusion, it has now become possible to understand the energy conversion mechanism leading to matter creation events in operation inside the cores of planets and stars, in terms of the gravitational interaction theory, which I have developed and is based on Planet X observations. Matter creation occurs as a result of the normal evolution of a celestial object, be it a planet, a star, or galaxy, as well as in response to a Planet X system object closely approaching a celestial object, when the Planet X system object is large or of a comparable size to the core of that celestial object. In order to support these energy conversions, the core of a living celestial object must be in a liquid plasma form, whilst Planet X system cores are dead and seem to be in a solid form. And these are the references. This is Dr. Claudia Albers, Planet X physicist. Thank you for watching.